that before in like a different talk.
All right. Hello and welcome to Teaching Python. This is episode 116, and today we're going to be talking about natural language processing with Ines Montani. My name's Sean Tiber. I'm a coder who teaches.
And my name's Kelly Schuster-Paredes, and I'm a teacher that codes with a hoarse voice.
Yeah, it's been a little bit of a rough start to the school year, huh? With getting a little bit sick before it all begins.
Yeah, tomorrow's the first day with the sixth graders. I'm so excited about installing Move for the, I don't know, how many, 55th time?
Yeah.
I can't wait.
It's all downhill after the first 52, so.
That sounds fine.
Ines, welcome to the call. It's so good to have you here this week.
Yeah, thanks for having me. Very excited. Yeah, I'm kind of new to the whole teaching side of things. I don't have kids, but we had a Ukrainian family staying with us, and the 12-year-old was like really taking to programming. So that was kind of what really got me interested in, okay, how to teach him more. He's really smart. How to do any of that? I have no idea. And yeah.
Well, we're happy to share what we've learned so far, and I love the idea of talking about natural language processing with students, because I think it really brings coding and algorithms to life when they can interact with the program that they create.
Yeah, no, it's real. That's also what really attracted me to the field. It's not just abstract programming. You're really working with something that's like super familiar, which is language and text.
Nice. That's cool. Well, we'll get into that in a second. Before we begin, we're going to start where we always do, with the wins of the week. And that's something good that's happened inside or outside of the classroom. And Ines, we're going to have you go first this week and share a win that's happened for you.
Yeah, so this one is not specifically about programming itself, but about the community and the Python community, because we, as Explosion, we are sponsoring PyData Amsterdam, which is happening next month. So we're right in the middle of preparations. I don't want to reveal too much, but we're planning things for our booth. It's our first time having a booth. We're going to do cool activities for the community and just getting ready to meet people. Like, I feel like it's one of the best parts of Python is the community around it. And so there's been a lot of excitement in our team.
That's probably the best thing for me too. I think that's what kept me into Python, is all the people that we've met. The community is so welcoming, and when you're giving some talk or explaining stuff, and everyone's just so supportive. Everyone wants to learn all the time. I think that's why I like Pythonistas. They just want to learn all the time for no reason.
Yeah, and it's a very welcoming community to anyone, and yeah, that's what I love as well.
Yeah, I love that everyone's willing to share and help. I mean, no one's like, "Oh, I can't talk to you about that." They're like, "Oh, no, let me teach you about what I'm doing, or show it to you, or check out this cool thing that I'm doing." It's a very sharing, open community that I really enjoy.
Yeah, 100%.
Kelly, how about you?
First? Oh, me. So I'm going to take my win from last week, and it kind of goes with what we talk about, or sort of talk about. But I did a AI for beginners presentation for teachers teaching teachers last week. And it was the only one that was offered. And I did it with a colleague. It was fantastic. The doors had to be opened up. People were sitting in the hall. It just goes to show you how many educators want to learn about what's going on with AI. And I kind of talked to them a little bit about LLMs and explained to them this is what a large language model is, and this is kind of what's going on. Very basic, didn't go into any coding. And I kind of explained to them, like, it's not just ChatGPT. That's not everything in the entire world. So just stop saying that AI is ChatGPT. Let's just talk about everything that's been happening for the last 60 years. And, it's not brand new. It's just hit mainstream news channel and, change your channel. There's other things. So it was really cool. And a lot of people were interested, and it was such a good win. And people wanted the presentation, and they wanted all the links, and they were just really, it's a little bit less scary when you introduce something as it is for real and not just the hyped up version. Right. So it was a really good win. And I wish I could offer that again as another talk for educators. But yeah, I was on a high last week. I think that's where I sucked out all my energy.
That's really great. I know we've been having a lot of conversations about that at work as well, as like what's the right role to use for AI, not just for writing code, but for like all of the other things that we're building and doing, and where can we use it. I mean, just even things like, we generate a huge amount of security log data, and being able to use that, trained models to spot for anomalies and potential intrusions and things like that is hugely helpful, because it's such a small, small positive effect, right? You could have, billions of lines of log data, and you need to find the right two, right? And it's challenging, and it's a hard problem, and it's a really important one. So, a lot of conversations in education and enterprise, like everybody is talking about how we can leverage this. So I'm definitely not surprised. For a variety of reasons, there's a huge amount of interest, and you're also a really good speaker. So I think that helps together.
I had a good co-host. It wasn't you, but it was my counterpart in Boca, and she did a great job. So we did it. I would have much rather had a presentation with you, Sean. Sorry.
Yeah, we'll do that another time. For me this week, I'm gonna pick a small one. I rebuilt my CircuitPython lightsaber this week, and it was really cool. It was, the real win was not the lightsaber. The real win was just building it again, and like going through the code and remembering what it felt like to create it for the first time, and see all the upgrades that the Adafruit team has done with some of the hardware that's being used. So it is it's using a new Raspberry Pi 2040 microprocessor now. So it's smaller, and they took all of the prop maker controls for like servo controls, which I'm not using, but the NeoPixel, the speaker amplifier, the accelerometer, all the stuff that was on a separate board is now all fit onto a tiny little feather board. So it's even smaller and lighter, and it's just really cool to see that and have that feeling of like, wow, I can make things and I can build stuff. And
yeah, I actually so relate, because I'm totally not a hardware person, but like recently I was like, okay, I really need to play with this now, and like I can program. So it's like, and yeah, like for those who want to check it out, I wrote a blog post about it. I had this really stupid idea to build a machine to pet my cat remotely. Because I figured, well, it needs this robot arm, and then I attach this brush, and then anyone from our team remotely can then use an app and pet, and because everyone loves our cat. Well, it didn't quite work like that. Like I've included the video. It's not, the cat's quite scared of it, but it was very satisfying to build. And I also used Python for the backend.
Yeah, I'm not sure that cats are the best in the like. They might be like looking at it
made so much sense in my head, but then the cat's like, what is this?
It can now just be changed. Like, just tell Ines, pet Ines, to transfer the pet to the cat. There you go. You can just say, like, everyone will just go pet.
Yeah, the web app's great. It had like this hand that you can that follows your cursor and that you can move. I was very proud of that too. And yeah.
That reminds me, I think one of my first hardware projects I did was a servo arm that had, I don't remember, Kelly, you maybe remember this, and I don't know if you've seen it, but there was like a board game called like Don't Break the Ice, where you had like a character on top of like some ice blocks, and you had to like tap out the ice block. So anyways, it came with this like little green hammer, and it kind of was like a Jenga like game where like eventually someone taps out the wrong block and the whole thing comes crashing down, right? So I took this little green hammer and I put it on a servo, and it would ring one of those like service bells, like the little tap like bells you put at a front desk or something. And I made it so that you could ring the bell from Twitter. And so every time it got a hashtag, it would like ring the bell. And so every now and then I'd be sitting at my desk, whoa, like, but like, I love those ideas because they're fun and they're silly. And I was talking with my team about this week. Like, we learn more from building something by having this like stupid idea that we think will be fun to make, and we don't know how we're going to get there. And the process of getting there is what makes it a learning experience.
100%.
Yeah. So, and
Crazy.
If we went into my list of fails this week, it would be a much longer show. I think this has been pretty rough between trying to parent and be productive and everything. It's my list of fails this week is pretty long, so we won't go into that. But just want everyone who's listening, if you're also failing your way through the week, you're not alone. I'm right there with you.
Me too. Mine's the software and ebooks and trying to get everything up and running. My goal was to get everything up and running by tomorrow, and I still have one book that's not running in ClassLink, but luckily the teacher's amazing and she's super supportive. She's like, "Don't worry, we never open the book until like the second week of school." So fails happen, and I'm at the point right now where I'm like, okay, it's Friday. Let's get these kids in the door. So
yeah, I mean, even in our company, like, yeah, we build fancy AI, and people are like, wow, you do so much, but like a lot of the stuff you do doesn't work, and they're like, all kinds of. I actually have this document where I collect like the funniest bugs, all kinds of like weird things that happen that like I don't know, drove us crazy trying to debug, and then it was like some really interesting reason, like I don't know, a Unicode character that looked exactly like an E but was not an E in the file name, and then PyTest doesn't pick it up, or you get like some weird failures when you install a library, and it's like, why is this happening? And then hours later, we're like, that wasn't an E.
That's funny.
One of my fails this week was from a bug I introduced 9 months ago and caused a 12-hour outage. So these things happen.
Past me.
Yep.
We're gonna have to have a fail of the life, the fail of the daily thing kind of show. But let's talk NLP. Let's talk NLP.
Yes, let's get into it. So Ines, let's start with just a little bit of background about yourself, the work that you're doing, how you got into this space. What is NLP for those people who don't know what it means or what it stands for? Because every 3-letter acronym has like 25 different possible explanations, right?
There is the other NLP, and they had the NLP hashtag on Twitter for a long time, which is why the natural language processing community, which is my NLP, used NLProc as the hashtag to find each other, because NLP was used by neuro-linguistic programming, which is a whole different thing, and also doesn't have to do anything with like the type of programming we're talking about here. But yeah, it's a thing. Yes. So, well, to go back, so I don't actually have the classic like tech programming background. I was like kind of an indoor teenager, grew up on the internet, and was making websites. So when I think we got a computer when I was like maybe 9, 10, and then at some point I discovered that Microsoft Word lets you export pages as websites, and then you could upload them to the internet. And maybe nowadays that's really normal to people, but back then I was like, whoa, mind blown. So I was making websites, and that was even, I don't know, as a younger kid, I would make like little magazines, and that was always like a thing I enjoyed. I'm like, great, I can do that on the internet. And then I kind of went from there and really went all in on like making websites. Then it was PHP, WordPress. So that's really how I started programming, and it's always followed me ever since. I studied communication science and linguistics. It was like, at the time, it's interesting, like looking back, it all worked out, but like I just didn't see myself as a programmer back then. Like I was quite young when I finished school. I was like a girl making websites, and I just thought of like programmers and computer scientists as like, these like boys I knew from school, and I was like, I don't fit in here, and so I didn't I didn't go for computer science, but it just always still followed me around. But I did linguistics as part of my degree, so there was always the language thing. And then I worked in media for a while, and then by coincidence I met my co-founder Matt, who had the much more classic academic background. He was a linguist, then turned computer scientist, did his PhD, was really into like this kind of idea of like, if we want to analyze language, we need to do that empirically and properly. And that means we need to analyze a lot of it. And that means we need to write good programs, because if our programs are slow, there's no point. And even the internet and the tech is growing faster than computers are getting faster. And so that's how we got into like really writing C code and writing fast software. And he had just left academia because he saw that companies wanted to use his research code, and because it was the fastest, it was like on the top of leaderboards, and companies were like, oh, can we use this in production? And he's like, yeah, now that's like research code. It's supposed to exit, print a number, and that's it. And but that's kind of what inspired Spacey writing it, like, which is an open source library to analyze large volumes of text and work with text in Python. But that was really designed from the ground up to be used in real projects. And not just academic research. And that's kind of what got me started in that area. I started working on the open source library, and then shortly after, we decided to form a company around it and really focus on developer tools around working with machine learning, but especially around text. So training your own models, building pipelines, finding out more about text, which is, nowadays it's clear it's a use case in pretty much any field. We all have text. We've amassed text over decades, and now we're like, wow, we have way too much text for anyone to read, and we want to find out more about it. And
I think it's kind of a subtle thing too, because as humans, right, like we're trained our whole lives to process text and handle text and think about the meaning behind it, right? And I think anybody who's taught English before, taught language, really like understands the struggle and the development, the growth that happens. But by the time you become an adult, you read and you write and you like input text, you output text, you're able to find nuance and meaning in text. But to look at that through the lens of analysis, right, of extracting or quantifying meaning from a given text and being able to classify it is something that I think is a really hard problem, right? It's not something that's like, oh yeah, it's so straightforward, we can all do it. It's
I mean, even for humans,
complex.
like ask humans, or like one experiment I often do, or like when I give talks, I ask, like, okay, take these two sentences. I love cats and I hate cats. Are they similar or not? And then you can take hands, and often, depending on the audience, you might get a 50-50, or people can argue about that, because it's often about like similarity. People think, hey, that's like easy, I should be able to tell that. But it's like, well, it depends. If, out of all the things you could possibly say in the English language, those two sentences are extremely similar. They express like sentiment about cats. But if you're building, say, a dating app and you want to match people up based on their profile text, then that should be like really dissimilar, because that's like opposite sentiment about text. And they're like, that's just the tip of the iceberg. There are tons of these things where even humans disagree, and where there's like a lot of knowledge and a lot of it is very specific. And it's hard for humans, it's hard for machines, but there are also things machines can just do better than humans. Like machines can remember stuff. Like it's a lot of the things you can now do with computers and with NLP are very, very difficult to perform for humans, because you can't keep like thousands or millions of documents in memory and then form connections between them. That's simply like not feasible.
So let's back up a little bit, but because it reminds me of this, funny, I don't know if it was Instagram or something, but you're flipping through the words and it's like hair, Hair. And we put a TH. It's not there, and it's all these languages and different pronunciations. I was just thinking about this joke. But when it talks about NLP, natural language processing, what does that entail? If you can break it down a little bit.
Traditionally, I mean, I would have initially said it's usually about taking text as input and outputting something about the text. And often it is used when talking about structured information. So finding things in text that go beyond just keyword search. And that can be linguistic stuff as well, like what's the verb, what's the noun, who does what to whom. These things are actually really important for understanding text, but also things like what's the text about, what persons are mentioned, what companies are mentioned, and then doing stuff like, oh, is this company that same instance of the company Microsoft, or is there someone else? Like that's all. And I think a lot of people, especially nowadays, would also include more generative things in that same field, which includes even something like machine translation, where a text comes in, a text comes out, and of course things like ChatGPT, anything dialogue. But basically, I think what we all agree on is, well, it's text. Text comes in, and something related to that text goes out.
So depending on what you put in, and I'm thinking sort of because it's the NLTK library, which is similar to the Spacey. Is that sort of correct? That was
back in the day, like when Matt started developing Spacey, NLTK was kind of the only main library around. And that had a slightly different focus, because there's a book that goes with it, and it was really designed for teaching, as well as using it for practical things. So it implements all the important algorithms back at the time. So there was a different focus. Whereas for Spacey, we always said like, hey, we implement one algorithm, and that's like the best, and we try to have like one model implementation, and focus on, because there's less of a focus of, hey, we show you different things you can do, and more like, here is a way to do a thing. But yes, that's definitely the same direction.
And so, like,
sorry, I think I just kind of cut you off there with like a tangent, and now, yeah.
And now, so I'm trying to think about how to make this real for people too. Like what examples of things you can do, right? Because we're giving it basically just strings of characters, right? Like here's a bunch of symbols that go into these tools. Yeah. Some things that we can do that, right? There, you mentioned sentiment analysis, right? Like, so what is the sentiment of this text?
Yeah.
What are things?
Your spam filter does something like it. Like an email comes in, and then it predicts, is this spam or not? And there are like a lot of different factors that go into it. I'm sure a sophisticated spam filter also combines that. It's not just one model, it's like a lot of different signals, but ultimately that's like a very classic text classification problem.
Nice. So there's like sentiment classification. There's summarization, right? So I've seen some really cool examples where you can take a large document and summarize it down to an executive summary.
Yeah,
and
that's
keep the meaning,
more
right?
of a generative task. And
Yep.
then other things that are less visible but also used a lot are things like span prediction or named entity recognition, which is, say you take a text, is that a person? Is that an organization? Is that a country? Stuff like that. That's often very useful on the way to other things. Like if you want to fill a database, or you, from more boring things like processing insurance claims or anonymization, that's like actually super important in a lot of areas. There's strict rules about personal data, especially, for example, in the medical field. There's like one company we recently talked to where, hey, if doctors are talking, for example, they shouldn't, there's certain personal information that cannot be shared, and you can use the machine learning model to predict that and alert, hey, that looks like a person.
And that I think is the key. So I'm thinking, the kid in me, the teacher talking to a student. Well, I could just put everything in, in ChatGPT, or I can just put it into some other generative AI. Yes, but and I think that's the difference between running your own or making your own kind of NLP project, because it's more specific to your specific goal. And I was reading a little bit, and I was watching a couple of your talks. I think it was a EuroPython talk. It was like, it was about the fact that you start with a problem. Yes, I can say, oh, I have all these recipes from home, I don't know, from my whatever grandmother, and I want to get the most common ingredients for all of it. That's something, I don't want to dump all my grandmother's recipes in there, because I don't want the whole world seeing all my grandmother's recipes, but it would be something that you could make for yourself. Is that kind of correct?
Yeah, I think exactly. Especially because this really, to take a step back, it really comes down to this really fundamental thing we've always had, which is we want to be telling computers what to do. That's why we program, and that's the fundamental problem. We know what we want, and we need to find a way to make the computer do that. And there are different ways to do that. Like before, machine learning was viable. You could write rules, so you can write regular expressions and stuff like that. That's an approximation. And with machine learning, that was actually really cool and new. You can, instead of just writing logic, you give it examples, and you can really give it these examples, show it to the model, gets a point if it's right, gets a minus point if it's wrong, like very, very simplified. And then it builds up these statistical weights. And then hopefully if it sees other stuff that's similar, it can make the right decision. And that's kind of a big plus, because if we can express something in examples and can generalize, that's great. And now there's a whole other way, which is the prompting. So we can come up with a prompt and with a question that hopefully gets us what we want. And there are pros and cons to all of that. Like the prompt, obviously it's like fast, you can especially for like everyday life stuff, it's really easy to just ask it a question that's general and get like a good answer back. And then it gets a bit more difficult if you have something really specific in mind, and especially something that's really domain specific, because you have this very general broad model that's like kind of, very wide, but not very deep in that kind of sense. So and there it can, if you know exactly what you want, you can create examples. It can be a lot more reliable, faster, easier, more private to just say, hey, I create a bunch of examples, and then I can train a system to do exactly that and understand exactly what it does. I can analyze where it's wrong. And there are a lot of use cases, if you like, really care about the outcome and really care about the problem, where that's absolutely worth it, because you can easily, if you hit a ceiling, then you kind of need to, you want to build something better. And I think previously, Sean, you mentioned like the fraud detection, or like logs, or like, what was it, security stuff. That's like always kind of a race, against each other. And that's one of these cases where I think I called it better is better. Like, you don't want a model that does like surprisingly well, given it's not trained for this. You want like a model that's as good as it can get. And that's worth the effort. Companies spend millions on this stuff. And the fact that we have to create examples to train a model, it's like a feature. It's not a bug. It's like an opportunity.
Well, I think that makes a lot of sense too, because it also, like we've talked about, I think Kelly and I have talked about this before. It's a lot easier for us to learn and understand through examples that are given, right, as humans. And so it becomes easier for us to create that. So I'm thinking about, as you're describing this, one of the things, just like the lightsaber that we talked about earlier, finding a project and building towards it, right? Or finding some crazy idea, or the bell ringing thing, or whatever it is, having some crazy idea and finding a path to making that happen is where real learning happens. And so where I'm seeing this opportunity with natural language processing is that there's a whole section of or a whole domain of project ideas that students and learners can have, where they have their interests and they have things that they want to be able to do, and being able to provide examples to the system that they create to say, this is the type of thing I want you to find. This is the type of thing I want you to go look for, right? And
and also the consistency, in that, that's actually the hard part. And I think, again, that's also something that's not, in my opinion, talked about enough. And that's often, because it's, it's not what the research is about, but like the hard part is not the algorithms. Like, sure, if you want to learn about it, it's good to understand how does that work, but that's pretty solved. And a lot of the optimizations there, it matters a lot less. What usually it always comes down to is the examples. And if you analyze those, you often, there's actually, I think even for people who are learning, there's a lot of interesting stuff you can find out there. Like even if you let several people annotate and create examples on the same data, and then compare that and see, where do people disagree? And then you can talk about it. And then you very quickly have like very deep conversations about language, or like, I don't know, stuff like, is the forehead part of your face? That's like, people can debate that for hours. So there are a lot of these things where you could show, hey, this is like inconsistent data that you created there. Like, here you included the doctor in the person name, and here you didn't. No wonder your model is confused by that, because it's now trying to make sense of, why is it this way here and why is it this way there? And there is no sense. And that's what a lot of problems really come down to. And I think that is something you kind of don't see and don't get to experience if you just interact with a black box over an API.
And I know a lot of our... Oh, go ahead, Kelly.
I was just going to say, like, I just got one of those ideas again as you were talking. I can see a lot of educators going, oh, what if... Because, we're talking about AI detection or plagiarism or everything. And I'm thinking, oh, can you imagine? And you can add in a whole bunch of the kids' data or their writing over the years. And then, flag, instead of like having this massive AI detector, you have actually a single student, because that's what it is. It's about the data that you put in. So I think when you control your own project, you can control your own data. You can talk about the biasness of the data or whatever's might be skewing your outcome. And I think that's what's neat about having made your own product, your own project yourself with that kind of feature. But I was like, oh,
and also actually,
cool.
bringing up the question, even something like, bias is much easier to look at in that context because, you're really doing something with a specific purpose rather than having this model that's supposed to do everything and then can, produce really bad things under different scenarios. Like, if you train model on like, ancient texts, like, yes, you actually, even the weights you initialize it with, you sort of want a lot of this to be biased because the text is biased and, you don't care about like, there are a lot of scenarios where it's like, nah, that's not where you want like a model that's optimized for an equal representation of men and women because they're literally like no women in this. And that's like a problem, but not, the model's problem. Or if you're analyzing, I don't know, online comments with hate speech, you really don't want a sanitized model because otherwise it's never ever seen hate speech before. And then you can misclassify that, or like your nice email filter will hallucinate a label. Like if it's never seen bad language before, it will hallucinate a label, and then your accounting department gets forwarded all the hate speech because your model has hallucinated that this must be accounting because it's kind of weird. So it's like there are a lot of these things where like, hey, really controlling what data goes in your model is like, useful. And also really helps understand how these things work.
And I can see where you can make this really fun too, right? So a lot of the things we talk about is, solving a problem, but you can also make it very entertaining also. For example, like an English class where you train a model on all of the Percy Jackson novels. Like here's all the text from Percy Jackson and The Lightning Thief and all of the other sequels. And now everyone has to write a short story, and we're going to see if we can make it trick the model into thinking that it's actually a Percy Jackson story, right? The same style, the same content, right? Could be super fun, right?
That's a cool idea. There's also the Spacey community has like some really awesome projects. Like there's one model pipeline called Hobbit Spacey. People have trained pipelines for Latin. Like there's a lot you can do, and actually, I've never really seen it from that perspective, but even really like doing some of these annotations yourself, even with a group of students, to really see, okay, if we're training from labeled examples, here's how that process works. And then you go through like, here, I don't know, Dave, why did you disagree with Alex here? And it's like, it's interesting to have these conversations about the nuance of language. And actually, these are, as I said, I think these are skills that are much more important than a lot of programming skills. Like we had a team from The Guardian use our tools, Spacey and Prodigy, to build models, and they wrote like really detailed annotation guidelines. And you could tell that like, hey, they're like journalists who really used to thinking about nuances of language. And of course, they're really good at that part of it. And that's something that, a lot of teams are missing, and a lot of skills that don't get enough focus.
Yeah, I love that. Just the idea to tie it into other domains and other areas and make it something that brings the language to life.
Yeah, actually, now that we're talking about it, I just had an idea, because we could maybe talk about this a bit more later. Like our first product, or the first developer tool we launched is an annotation tool called Prodigy that really brings together the scriptability of Python and a UI for creating these annotations. And so you can run that locally, load in your data, create annotations, and then it even has workflows in it to like compare for disagreements. You can train a Spacey model straight from that. So if someone's listening to that, then thinks like, hey, this could be awesome to do in my group with some students, to really do a bit more hands-on annotation work. We have a research license program. I can give you some info you can put in your show notes after this, and we're always happy to support these sort of projects. And and of course, if someone tries it out, let me know how you go.
Kelly, you're muted.
Oh, you're muted.
That happens when you're coughing and you're covering up. I want to switch gears a little bit, and because because I think you have a talk coming up about maybe the future of NLPs and the LLMs, or maybe you already had the talk. I can't remember. I was looking, and I just, as a person that's learning about all this stuff, go. I don't even know what the question is, but go. Future of NLPs, LLMs,
there are
machine
a lot of,
learning.
It kind of makes futurists out of all of us. Like, there are a lot of takes. There are also, a lot of takes I don't necessarily agree with. Like, you have people who will tell you with a lot of conviction, and also, motivated by everything you see when you scroll through LinkedIn every day, that like, oh, large language models will like replace everything, and we don't need programmers anymore. We don't need Python anymore. We don't need anything else anymore. But from our practical view, that's not where I see things going. And actually, I felt it's a bit of a short-sighted view of things, because it also, it doesn't really distinguish between, just capabilities that are generative, which, yes, now work so much better. Like, you can generate text at a really high quality. That's great. And that's an effect of like the models just being bigger. But there are all these other things people are doing with NLP and have been doing for the past decades in companies. I would say the majority is much more around information extraction, predicting things. And yes, large language models can do that. But currently, they are a lot worse at a lot of these things, especially specific tasks, than what is out there. If you just fine tune a model with just more examples. Like, if you have no examples, it's still nowhere near the performance, and it all makes sense, like, as we talked about. And you still have this problem of like, parsing this output, which is text, back into something structured, which also has a margin for error. And some people might then go and be like, well, it's just a matter of time. The models will get bigger and it will all get better. But there's still, even if model gets bigger and you can, get much, much better accuracy than now, it's still really, there's still kind of no logical way in which it beats, a model that's very specifically designed and trained. There's like, there's a whole next step that goes, okay, now we have this massive model that's pretty good. How can we make it smaller and even better? What can we feed it to make it do even more? And that's, if that's totally possible. And I think that's where, we see the industry heading. Like, that the sort of very futuristic idea basically assumes that companies and everyone will like drastically change everything they've been doing, and use completely different technologies for everything. And that's not something we've ever really seen in the past. It's more of a very gradual development. And the research backs this up. It's like, yes, they're like huge changes and huge things that we couldn't do before, but there's also, a much more nuanced take I have on the future.
Yeah, it's interesting. Okay. You brought up a good point about kind of the evolutionary incremental change that a lot of organizations take, right? They aren't necessarily looking to transform their entire business. They want to just make parts of it better, right? Or solve specific problems. And I think one of the things that struck me coming from that world before I started teaching around enterprise and around the way like the approach that everyone was taking, that became very familiar. And then when I came to teaching, especially in middle school and like with these, kind of teenage, early teen students or preteens, was amazing to me was that they did not think that way at all, right? Because everything was new to them, right? Like there's no incremental change when you just learned about this 6 months ago. So why not do something completely radical, right? Especially since they also have an underdeveloped sense of risk aversion. But they tend to, like, because everything is new and everything is equal in their minds, there's no history, there's no pattern of this is the way we've done it before, or these are the things we want to do. We saw a lot more experimentation, with Kelly and I, in terms of how students would tackle problems and how they would look at things, and they were willing to go try the completely different way of tackling a problem. And I wonder if, as we bring these like kind of machine learning NLP ideas and models into those younger learners, if we'll see more of that kind of big risk-taking strides, like let's go combine two things together that nobody thought to do. What interesting thing could happen?
Oh, that's an interesting question. Like I hadn't, but I definitely think there's kind of a new generation of people who are much more like, I don't know, how do people call it, like AI native, and you know, have a very, like, I don't know, very different like approach to things. But I do think, of course, there's also, you know, if you like, yeah, risk taking is good, but there are also, you know, like aspects, especially if you are, you know, if you have this like sort of essentially black box model, there are a lot of things that can happen that are much more difficult to predict than if you just like wrote some if else code.
Right.
And so, but I do think that again, that's just a different learning process. Like, you know, when you wrote your if else code, you realize at some point, okay, the whole thing crashes, or depending on the programming language, you just get like a seg fault, and then like you have no idea what went on there.
Right.
And it's sort of the failure modes are all different, and that's something we have to adjust to more. But yeah, to the original point, I think, yeah, transformative technology does not mean that like we just throw everything away and like do everything different, and especially if different means more expensive and worse. Like that's not how transformative technology works. It like
that does not go over well in the annual performance review, right?
And improves things that, you know, like there's no shortage of things we want to do as humans and companies want to do and have always wanted to do. And, you know, even before, maybe a team could do like 2 projects. Now the prototyping, that's where LLMs are great. You can get started more quickly without having to annotate examples. That's like, you know, even I think also actually for teaching, like before, it's like, it was actually kind of, you know, difficult to explain these things and really walk through the process, because you need to do so much work to actually get to a system that produces some output, because you have, you know, you need to label some examples to even have a model that learns, and then you need your evaluation data. And at least with large language models and with like, you know, these plugins, like in Spacey, we have a whole add-on where you can basically have the same experience and the same data structures, but powered by say OpenAI GPT-4, or even open source models that you can download if you want to run it locally, and then you have a thing that's working immediately out of the box. And then you can work on improving that and say like, okay, let's create some evaluation data. Again, we will always need that. You always need to empirically be able to tell, is the thing doing what I want? And for that, you need examples where you know the answer. I mean, it's like, actually, I guess from a teaching perspective, that's like, you know, the most fundamental thing. It's like, you know, a lot of exams, like, you know, they are like, it's, you know, there's always a component about like, oh, you need stuff where you know the answer. And then based on that, you can decide whether someone is right or wrong, and how they perform.
How do we know they're learning, right? That's
how do we know? Yeah, exactly. It's kind of similar. It's like, I do hope that, you know, yeah, nowadays, yeah, it's not all multiple choice exams, but there is a component of that, and it's similar for a model. So, but we can get to a working state much quicker, and I think that is a big transformative part. Not that we just throw everything out.
It kind of, I was just thinking, it kind of reminds me of like large language model, give me feedback for a student. It's going to give me, yeah, you're doing well, or keep focus, or sit down, very generalized. But if we take in the other side where we're getting more specific for the job, we're getting more specific for a situation, it's going to give more specific feedback, stuff that can actually be done to improve. So that's kind of where I'm getting my metaphor on it of the difference of the two, summarizing what was just said.
Yeah,
I think
I find it fascinating.
But I think oh, sorry. Yeah,
I said I think it's fascinating that we're taking all of these, you know, all of this amazing capability, all this capacity that we have in terms of, like, to your point, you know, millions of documents together and being able to relate them and make connections and hold all this stuff in memory. And we're having a very old conversation about a very new topic, which is the role of generalization versus specialization, right? And like, where is it more valuable? Is it more valuable to have generalists and people who know a lot about everything, but maybe not as much detail? Or is it better to have specialization where we have models or people that can really focus their capabilities in one area and create more value in that space. Like
it's kind
it's
of
just
both.
Yeah.
But I think both, like in the world, and also from a technical perspective, I think the answer or the highest value lies in both. You want to, you like a very generalist knowledge and capability lets you get started quicker. But then, you can, you can kind of take it to the next level with specialist knowledge.
Quick question. Is there generative and predictive NLP? Like, does it depend on the way you do code, or is it just generative for more of the large language machine learning AI?
I mean, I don't know if it's like, it's partly, I don't know if it's something we've coined that way, or if it's something everyone uses, but like I do think it's a super important distinction, which is generative, you're really producing new output, and that's kind of also really sort of the underlying idea of how a lot of these models work, or what now it's really unclear. People call everything large language models now. It's really confusing. Like there are a lot of these foundation models that have been around for years. And the architecture is kind of the same. The algorithms, it's all the same. It's just that there's now a new term for it, and people are using that even for older stuff. But that's basically this idea of, hey, let's try and teach the system to predict the next word. That was really in a simplified way, the underlying experiment. And it turned out that not only do you very effectively train the system to predict the next word based on a huge corpus of raw text that actually works well, but it also, the weights you're building up under the hood that make this possible kind of naturally and logically encode a lot about the language and the world, because you have to encode that in order to be able to predict the next word in context. And that was this whole revelation, basically, or that was the finding that really changed things years ago. And because not only can these models produce text, but they can also be used to like initialize other models, like for tasks where you really have a component or machine learning implementation that has the job of taking in vectors representing a text and outputting some label, which under the hood it's also like an integer, like it's not, that's the job. And that works much better if every word gets like a weight from those statistical weights that were trained by predicting the next word, because then every word in context has like all of this knowledge encoded within it, and then these models work better. So that's the kind of whole, that's how it all started, and that's the whole idea. And then people went and said, oh, what happens if we make these things bigger? And then like OpenAI was like, okay, hold my beer, what if we make this even bigger? And it was just like, oh, it's just like, it's big, that's like, and then wow, it like actually works better and better. But I do think it's, when talking about these things, I think it's incredibly important to differentiate between generative tasks where really the output is a text that includes translation, summarization, and then tasks where the output is much more machine facing, where it's like structure about the text. The text goes in and then it predicts like for every word, is this part of, say, a person, or from which word to which word are words about a company name, and or even much more linguistic things like base forms. Sounds kind of boring these days, but it's actually super important, especially for languages that are not English. Like even if you want to make a word cloud, you kind of don't want to, you don't want to include all forms of a verb. You want to include it once, and that means you have to resolve it back to the base form. In English, that's quite easy. It gets like a lot harder in other languages like German, Dutch. Like I think English is quite easy. Is also the language that has the most research done in it. So the closer your language is to English, the easier it is for NLP, because that's what everything was designed for.
It's giving me like a ton to think about. Like it's just, and I think that's the fun part about talking about NLP and thinking about it, is that it's bringing us back to where we started the conversation. It gets you to think about something that is very ingrained and intuitive, especially by the time you're an adult, the way we communicate, the way we express ourselves. And what also occurred to me as we were talking about this is that, the other thing that's interesting about this is that, we may have in our mind this idea of like, well, there's the perfect text that is correct and grammatically solid and expressive, and it's good text, right? But we don't speak that way. Like my last 3 sentences were complete gibberish, right? but but the idea of being able to look at real text and real language, the way people communicate, the way they speak, the way they write, the way that systems generate text and create output, generative programs, things like that. It means that we're really looking and working with real tangible things. And I think also bringing it back to your point at the very beginning, for learners and for teachers, what makes that real and makes it compelling is that you're not dealing strictly with theoretical or the abstract or that perfect idea of text. You're dealing with real things, real text, real words. And that's messy, right? And it's
and also I think there's
weird.
more. And I think one main point I would make is that there's much more than just generating text or ChatGPT. Like there's actually so much interesting stuff that's kind of at the intersection of human and machine, and especially extracting structure from text. There's so many fun projects even beyond like all the boring enterprise company stuff. Like I don't know if you like, there's so much even as a hobby project. Like if you're into Pokemon, or I don't know what like young people into these days, but like even something like that, you can imagine like a task of like you want to build the database of like everything that's like ever said about like every, I don't know, Pokemon or someone from like your favorite band or some other or sports that's like done as well.
It's got to be Fortnite. Fortnite.
So I don't know.
So we analyze what that person's saying. We know that they're going to come up and set an attack or something. I can see it now.
Or like something people talk about Fortnite all the time, and then they're different characters and they're different like seasons, and I don't know. I mean, I know nothing about Fortnite. And then you want to, from everything, from news articles, from Twitter, from Reddit, and you want to parse that, and you want to really find out like what is here my categories are person, I don't know, Fortnite season name, like I don't know if it has like different countries or different places, whatever, and you want to extract that, and you want to do that live over everything on the internet, which is going to be loads. And then over time you want to populate your database so you can query that and say like, oh, what were the most talked about things, or like what do people say about this? And that's like, sounds like it's kind of fun, but this is actually incredibly similar to like what a lot of large enterprise companies are doing, and what's like driving incredible value. And and there you would like, a good way is, as it did, you train a model specifically for that. You label a lot of examples, you highlight, go through them, highlight all the different entities you're interested in. Maybe your first idea is wrong. Again, that's also designing these label schemes, deciding what you want to predict. That's much harder than like training a model. That's the hard part. Even as you start doing this, you realize, this is ambiguous. I can't decide if it's this or that category. And then you're like, okay, let's scrap this. Let's start again from scratch. The world doesn't divide neatly into categories, and language doesn't either. So it's like, that's the work. And I think learning that will also teach you a lot about the models and the technology that comes out of it, and the limitations, failure modes.
What's I think I'm looking at the clock and I'm looking at the time, and I think we could probably talk for forever about this, because there's a lot of really
I could talk about this forever.
I think maybe the best place to wrap up is around maybe Prodigy a little bit, and where teachers can get started. So if you've got if you have an idea about what you could do with NLP, or you have an idea for a project. You mentioned earlier that you have Prodigy, there's research licenses, there's a community of people that are doing things with Spacey. Where's a good place for teachers and educators to get started playing around with this and getting a feel for what's possible and what they can do with it? Where should they start looking?
So I think we actually put a lot of work into the Spacey documentation. It also really goes through, like there's a Spacey one-on-one. I'm sure, I can send you the link to that, where it really starts at the very beginning, like what different things you can analyze about language with some code examples. Like it does assume a basic knowledge of Python, but also luckily that's something that's like, there's so many resources for that. But then there's really a lot of code. You can even run that in your browser and start experimenting with that and learn as you go. And then once you get to a point where you're like, oh, I have a great idea for maybe a text classification or named entity recognition model that I want to train on some raw text I have, like our Fortnite idea, or maybe I'm sure people have better ideas for what to do. Then usually, well, what you want to do is you need some examples you can train from where you know the answer. And of course, also some examples you can evaluate on. So you can actually check if your model is learning something, and that also has to be good. And that's where Prodigy comes in, because it's also a scriptable tool. You can write Python functions and integrate pretty much everything into it. And it also comes with a lot of things out of the box. So you can start annotating named entities. It opens up the web browser, streams in your text, and you can just start highlighting. That's like the most basic thing. You can also load a model in and improve an existing model, or just look at what does my model predict in an interactive way. And it has interfaces for all kinds of different things. And then at the end of it, you can run train, and then it will train you a Spacey model from these annotations you've collected and evaluate it. So there's a very interactive aspect to it as well. We always actually like doing kind of workshops. I know a lot of lecturers in university, they like to use it with their students because it's very easy to get people to really look at the data and have that connection, and not just have this abstract corpus that you calculate accuracies on. And and also university, they need to create data sets, and the students are like good workers. They can also produce data as part of their courses.
Nice. Cool. Yeah, it's definitely prompting some ideas for projects and hobby things that I want to do.
And nowadays, you don't need that many annotations anymore. It's like absolutely not, even if you're training a model from scratch with transfer learning, like if you start out with like good word embeddings, something like BERT, the foundation model, you could get by with like a few hundred examples. And if you have an efficient tool, which is again why we always built Prodigy and the UI to be efficient, like as little clicking as possible, just like really just the knowledge you really need. And then you can easily do that even in a few hours. You can create quite a lot of data, and that's like not that much if you get like your own machine learning model at the end. And that's like a model that runs on your local machine, that can even run on a modern MacBook these days. That's like no problem, and it's 100% yours. You can, I don't know, people have run it on a Raspberry Pi. I haven't really played much with it, but I know that's possible. So
I think you can run anything on a Raspberry Pi these days.
And so then you can actually copy your Spacey model and then run it from your Raspberry Pi. And I don't know, people can enter some text and then it can predict something about the text. So I'm sure they're like even cooler things you can. Or again, going back to the video games, like I don't know, you can stream your one where people like type in and chat. You can kind of stream that to your model and then predict things in real time about what people are talking about in the chat, or how is the mood today. I don't know.
I would love to like have it predict how good they are as a player based on how much they type or what they're typing, right? Like I think that'd be fun, right? Like there's all kinds of great ideas.
Yeah, there's so much.
Don't get them started, Ines. Don't get them started. We'll be here all night. We're gonna we sit there and generate.
I hope nobody sends me hate mail about like I don't know, my lack of Fortnite knowledge. I guess it's mostly
not at all.
Your listeners are mostly teachers and not the students, so I hope I'm safe. Yeah.
You're safe. Absolutely. I don't even know what goes on in Fortnite and my kids play it. I just know they run around screaming at each other on the phone, and they're like, come here, cover me. I'm like, turn it down. But anyways.
Well, I think we can probably wrap up here. We'll grab a bunch of the links and put them in the show notes and share links to Spacey, the documentation, Prodigy, Explosion, so that people can get a sense of the work that you're doing. Ines, thank you for joining us. This was really a lot of fun and
thanks for having
super
me.
interesting.
And yeah, keep me updated if you end up trying things like annotating your own data. Some of your listeners, definitely keep me updated. I find this super interesting. Yeah.
Excellent.
Cool.
Kelly, any announcements for our listeners this week?
No, but keep an ear out for my next project. You'll like this, Sean. Actually, I bought one of those magic mirrors. When you said Raspberry Pi, it reminded me.
Nice.
It's a magic mirror, smart mirror. It's a project for my exploratory. We'll see if we can put it together. It doesn't come with the Raspberry Pi, so I had to buy the Raspberry Pi. But apparently, we're going to have temperature, and I actually have a mirror because we have no mirrors in our bathrooms for some reason. Past 2 years, they took them out. They just never put them back. I guess they were like, it's easier to clean. There's no mirrors in there. So now I had a mirror that's going to be a smart mirror run on Raspberry Pi. We'll see. I might be calling you and getting some help.
Sneak me on campus. I'll help you set it up.
Sounds good. But nothing else happening. First, good luck to all the teachers that are starting for their new year.
Yeah,
that's it.
Yeah, we'll be here for you. If you want to get in touch with the show, teachingpython.fm is our website. You can always connect with us at Teaching Python on Twitter. I know we've said this the last few weeks, but if you're enjoying the show and you think it's valuable, share it with someone. Send it to someone directly and say, hey, give this a listen, or find an episode that you really like and share it with someone. Make that connection, talk about it, have the conversation with another person. I think that's really where, in this crazy new world of social media, it's the human connections that matter. So make a human connection, share an episode, have a conversation, talk about it, talk with us about it. We're happy to listen and hear about it. If you liked our show, if you disliked our show, leave us a review. Hopefully just the ones that you liked. Leave us a review on your favorite podcast player. It helps just give visibility so other people can find the show as well. And if you want to support the show financially, of course, there's our Patreon link. Thank you to all of our Patreon supporters who keep the show going. I know it may not seem like much, but it helps cover the costs of hosting the show, and makes it just nice for Kelly and I to see like all the different friends of the show who are helping us out. It's a really nice thing, and it makes our day. So, Ines, thank you for joining us.
Thanks again.
Looking forward to having you back in the future, and we'll talk more soon. So for Teaching Python, this is Sean.
And this is Kelly signing off.